Hey guys, welcome to another video. Now in the previous video we discussed about binomial expansions and how to expand them. If you haven't watched that video, I highly recommend that you watch that before this one. So in this one we'll be looking into some special cases of binomial expansion. But before that, let's have a look at a recap of how we actually do a binomial expansion. So as an example, I will quickly go ahead and make a recap. I'll just say x minus 3, x plus 2. So the way you would do a binomial expansion is that you would take the first term and multiply both the terms in the next bracket. So x times x, x times 2. So x times x is x squared, x times 2 is plus 2x. And then you go to the next term, negative 3, and then you do the same. Negative 3 times x, negative 3 times 2. So negative 3 times x is negative 3x, negative 3 times 2 is negative 6. Now, as you can see, there are two like terms, 2x and 3x. They are both like terms because they both have the same variable x. What you can do is you can add them together, and what you will get is x squared. 2x minus 3x is negative x minus 6. Now this is the answer you get when you expand binomially, and what you've got is a quadratic expression. We've discussed all of this in the previous video in more detail. If you want to look at that, you can go ahead and have a look at the previous video in this same playlist. So this is how we usually expand binomial expansion, and this is going to be the same way that we'll be expanding in this video too, except that we have some special cases, in fact two special cases that we'll be looking into. Let's have a look at the first one. Special case 1. The first special case is that both the brackets that we are multiplying are the same. For example, if I say x plus 2 times x plus 2. So when we have both the brackets as the same bracket, we know we can write this as x plus 2 whole thing squared. Now, if you didn't understand that logic, it's simple as writing 5 times 5 can be written as 5 squared. 3 times 3 can be written as 3 squared. So just like that, x plus 2 times x plus 2 can be written as x plus 2 squared. Now, is there any difference in how we will multiply that? Absolutely not. I'm just going to go ahead and do the same thing that we did in the previous video and that we did just now. So x times x, x times 2. That is x squared, and x times 2 is 2x. And then we're going to go ahead and say 2, the next number, or the next term, times x, and 2 times 2. So 2 times x is 2x, 2 times 2 is 4. Now, if you notice, what's the special case in this one is that you get the same term as the second term and the third term, 2x and 2x. And that is because it's the same number that is multiplying. So the answer finally ends up to be x squared plus 4x plus 4. Well, what's so special about it? Well, we can kind of put this into a pattern. The pattern would be, if you see x plus 2 whole thing squared, we can write it as x squared plus 4x plus 4. We just found that out, right? Now let's go over a few more examples in this and see actually what the pattern is, okay? So I'll just see x plus 3 times x plus 3. I'll see what comes out of this. So when I expand this, it becomes x squared 3x 9. So this is x squared plus 6x plus 9. So what I'm going to do, I'm going to list it down below. So I'm going to say, okay, x plus 3 whole thing squared, which is x plus 3 times x plus 3. What I got was x squared plus 6x plus 9. I kind of see a pattern, do you? No? Okay, let's go for another one then. How about x plus 5? Okay, so we'll go one negative because we've done two positives. We'll go x minus 5, x minus 5. So if you do x minus 5, x times x is x squared, x times minus 5 is negative 5x, and then negative 5x again, and then positive 25. Negative 5 to negative 5 is positive 25. And this becomes x squared minus 10x plus 25. So if we list it down here, x minus 5 whole thing squared, and by the way, you read it as whole thing squared. If you just say x minus 5 squared, what that means is x minus 5 squared. Just the square belongs to 5. So just to tell it out to mention that that square is not just for 5, but it's for the entire x minus 5. The way we read that is x minus 5 whole thing squared, or x minus 5 entirely squared, or something like that. Okay, so x minus 5 whole thing squared, as we saw, the answer is x squared minus 10x plus 25. If you observe very carefully, look at the term inside the bracket and the terms that come outside, meaning this plus 2 and this plus 4. It's always doubled, isn't it? Plus 2 has become plus 4. Plus 3 has become plus 6. Negative 5 has become negative 10. So they're always doubled. This is why it's called a special case, because in this case you see that each term in the bracket is doubled to get the middle term of the quadratic expression. And not just that, each term is squared to get the last term of the quadratic expression. 2 squared is 4, 3 squared is 9, 5 or negative 5 squared is positive 25. So you can see this pattern in all of the binomial expansions where both the brackets are the same. And therefore what we're going to do is we're going to create a formula that will easily expand these kind of special cases. So I'm going to write that formula as a plus b whole thing squared. We had to make it general, right? We can't be specific when it comes to formula. And looking at the pattern, you'll understand the first term of all these examples, if you notice, it's the x, and that is x squared. X, x squared, x, x squared. So in the formula, we have to write, if the first term is a here, we're going to say a squared. Right, now let's look at the second term now. So second term, if you see, it's 2x, and that's being doubled. So if you kind of multiply this 2 and x together, that is 2x, double that, 4x. 3 and x together, 3x, double that, 6x. 5 and x together, negative 5x, double that, you get 10x. So likewise, if you double this, if you multiply a and b, ab, and you double that, you get plus 2ab. Alright? And then the last term, as I mentioned, is just the square of the term inside. So if it is 2, so in the first one, it's 2 becomes 2 squared. 3 becomes 3 squared. 5 becomes 5 squared. So b has to become b squared. So this is special case 1. And we call this as perfect square. Call this as perfect square. So what's the perfect square formula? The perfect square formula is a plus b whole thing squared is equals to a squared plus 2ab plus b squared. Now if you want to prove that, what I'm going to just do is I'm going to go ahead and expand a plus b whole thing squared as a plus b times a plus b, and we do our normal thing. We just multiply them binomially. So a times a times b. So what we get is a times a is a squared, a times b is ab. And then the second term, b times a, b times b. B times a is ba or ab. It's just multiplication. You can write either way. And then b times b is b squared. So at the end, what you have is a squared. ab plus ab can be written as 2ab, as they are like terms, and then b squared. We can also model this, and we can say if it is a minus b whole thing squared, we can write that as a squared minus 2ab plus b squared. Alright, now that we've understood the special case 1, which is called perfect square expansion, let's look into some examples just to familiarize this formula to ourselves. Okay, so let's go ahead. We know the formula. These are the formulas. So let's do some examples. Example number 1. Let's say x minus 7 whole thing squared. Now we have both the plus and minus format when it comes to perfect square expansions. Let's go ahead and expand. So this x minus 7 whole thing squared is a squared minus 2ab plus b squared. Remember, if there's a minus in the middle, the middle term will become minus. That's the only difference. Okay, so a minus b whole x minus 7 whole thing squared will be x squared, right? I'm writing the direct answer without even expanding it. Okay, x squared minus 2 times a times b. So I'm just going to multiply 2 times the first term times the second term. 2 times the first term is 2x. So 2 times the first term times the second term. Now, you don't even need to write this. With practice, you will directly do these all mentally and directly write the answer. This is 14x. 2 times 7 is 14. So this is just 14x. And then square the 7 plus 49. Simple as that. So you double the 7 to get the second term, square the 7 to get the last term. Let's look at another example. Let's say x plus 4 whole thing squared. Well, that is x squared, the first term squared, and 4 doubled is 8. So it's plus 8x, and 4 squared is 16. So plus 16. Hope this is clear and hope this makes it easier. Let's go to a little bit more trickier examples. Third one. Let's put a coefficient for x here, 2x minus 3 whole thing squared. In this case, what I would do is I would just say how to make the first term. So if I look into the formula, a minus b whole thing squared is a squared. A is 2x. So 2x squared, right? 2x squared. This is minus. So minus 2 into a into b. Now you wouldn't put negative 3 here because you've already taken the negative sign in front. Okay, this negative sign is here because of the negative sign of b. So you don't need to go ahead and put another negative 3 inside. That will make it wrong. Okay, so since that negative sign is already taken out, just mention 3. Okay, plus b squared. B squared is negative 3 squared. I mean, always b squared is going to be positive because whether the b is negative or positive, when you square it, it's always going to be positive at the end, right? Just see what I've done here. What I've done is I've just applied the formula. I've considered 2x to be my a, 3 to be my b. So a minus b is a squared minus 2 times a times b plus b squared, right? So 2x is a, 3 is b. So if you have a look at here, I've just replaced a's and b's with their corresponding values according to this question. Okay, so what I'm going to do is I'm going to go ahead and simplify this. I'm going to say 2x squared is 4x squared because that square belongs to both the number and the letter, meaning 2 and x. So 2x whole thing squared is just going to be 2 squared, which is 4, and x squared, minus 2 into 2x, 2 into 2x into 3. So let's multiply the numbers together. 2 into 2, 4. 4 into 3 is 12. So that's 12x. Plus minus 3 squared is 9. So the answer is 4x squared minus 12x plus 9. And if you want to verify, you can go ahead and expand them the usual way, which is 2x minus 3, 2x minus 3. You can expand it using this method, the usual binomial expansion method, and see if you've got the right answer. Okay, right. So that is how you use the perfect square formula to get to the answer faster. So to make it even faster, what you have to do is keep practicing more perfect square questions, and you will even remember the formulas without even putting an effort to remember them. Right, so that is special case 1. So special case 1 is that when the brackets are same and when they are multiplying with each other, you have this perfect square case where you can write the answer directly without even expanding them binomially. Now let's have a look at special case 2. Special case 2 is when you multiply two brackets binomially, but then one bracket is a conjugate of the other. Now what does conjugate mean? Conjugate means conjugate of a plus b is going to be a minus b. So conjugate is just that the second term will switch its signs. Okay, so let's have a look at some example. X plus 5, x minus 5 is the same two numbers, same two terms, x and 5, but in one case it's adding, one case it's subtracting. Why is this special? Well, let's find it out by expanding. So x times x is x squared, x times negative 5 is negative 5x. Then we go to the next one, right? So we go with plus 5. So plus 5 times x is plus 5x, and plus 5 times negative 5 is negative 25. Now the special case in this question is that if you notice, the middle two term will cancel out each other. Minus 5x and plus 5x will just delete each other and turn into 0. Now this never happened before because we didn't have a conjugate pair multiplying together in previous video or in previous examples. But compare the special case 1 and 2. Special case 1 also had same two terms, but their signs were also same, and for that reason they added up. So 2x and 2x added up because their signs were same. But here again they are same but then opposite signs. So minus 5x and plus 5x, they won't add up because they're due to opposite signs. They will just subtract each other and just disappear. The final answer will be just x squared minus 25. Now let's look at some examples to understand the pattern. So we have understood that x plus 5 times x minus 5 is equals to x squared minus 25, right? And if you look at some other examples, like let's say x plus 3, x minus 3. If you look at this will give you, and if you expand this, you can try it out by yourself, this will give you x squared minus 9. If you go ahead and say x plus 6, x minus 6, this will give you x squared minus 36. I think now you would have figured out the pattern here. The pattern is when conjugates multiply, whatever terms that is there, x and x, the answer becomes the first term squared minus the last term squared. So the second term is 5 times 5, 25, right? So the idea here is in conjugates, the final answer is going to be the first term square that and the second term square that, but they will be subtracting. They will never add. This sign will never become a plus. This is always going to be minus, because the reason is that one is a plus, one is a minus. When it comes to last multiplication, they're just both opposite signs. So they will always end up as a negative number. So if I were to build the formula, I would say a plus b, right, times a minus b. Isn't it the case? Right? We have two terms both adding each other and subtracting each other. So a and b are adding and a and b are subtracting. So if you were to multiply them, the answer you would get is the first term squared, a squared, minus the last term or the second term squared, b squared. So this is the special case 2. So the special case 2 tells you that a plus b times a minus b is a squared minus b squared. And this is often written the other way around. So this is written as a squared minus b squared can be written as a plus b, a minus b. Now this is the same thing. I just swapped the equal sign the other way, but it's just the same thing. But what it is implying is that if it's a plus b, a minus b, we can write it as a squared minus b squared. And also if it comes to a case where we need to interpret a squared minus b squared, we can interpret it as a plus b, a minus b. Now the name for this special case is called difference of squares. Now why is it called difference of squares? That should be pretty straightforward, because difference means subtraction. Squares is a square number, so a squared is a square, b squared is a square, so we are subtracting two square numbers here. So that's why it's called difference of squares. So this is special case 2. So let's go ahead and see some examples on that. Let's say example 1, 3 minus x, 3 plus x. You see, 3 minus x, 3 plus x. So this is going to be 3 squared, which is 9, minus x squared. Clear? I mean, it doesn't always need to be the case where x is the first term, right? We can switch it up. So in this example, x is the second term, so it comes at the end. Let's have a look at this example where 2x minus 5y and 2x plus 5y. 2x minus 5y, 2x plus 5y. So two terms are subtracting each other and adding each other, right? So we can go ahead and say, okay, 2x is the first term, so 2x squared minus 5y is the second term, so 5y squared. So if you were to simplify this, 2x squared is 2x whole thing squared is 4x squared and minus 5y whole thing squared is 25y squared. That is the answer. And don't worry, we will discuss in the next video a lot more questions on difference of squares and on perfect squares. And that is it for this video. Hope you guys understood and hope you guys enjoyed this video. Hit the like button and subscribe for more videos. And please feel free to comment below if you have any questions or if you have any topics that you want me to discuss in my future videos. So see you in the next video.